You type kube-control apply, and a few seconds later, your pod is running. It is running on node 3. You never mentioned node 3. You never named a machine at all. Your manifest does not have that field filled in. So something chose for you, and here's the part that surprises people. The thing that chose has no power to start your container. It cannot reach your node. It cannot pull an image. Its entire authority is one string written exactly once. Everything after that happens because something else noticed that string. That is the Kubernetes control plane in a sentence. Nobody gives orders, everybody watches a shared record and reacts to it. I'm Nancy, and this is Trust Boundary. Every episode, we take one piece of your stack apart and find the line where trust changes hands, how it really works, what it looks like on the wire, and the one check almost everybody skips. Kubernetes calls this the scheduling cycle, and it runs for every pod you create. By the end of this, you will know exactly who picks the node. You will know the two phases that pick it: filtering, then scoring. You will know which field the scheduler reads and which one it completely ignores. Confusing those two is the mistake almost every team makes once. And you will be able to read a stuck pod and say why. 4 participants, you at a terminal. The API server, which is the only thing anybody talks to. The scheduler, which decides where pods go. And the kubelet, one of those runs on every node in the cluster. Draw the line here. The API server is the boundary. The scheduler never contacts a kubelet, not once. The kubelet never contacts the scheduler either. Neither one knows the other's address, and neither needs to. They only read from and write to the record in the middle. Watch that line because it explains every behavior that follows. You run kube-control apply with a pod manifest. That is one HTTPS request to the API server, nothing more. The API server authenticates you, then checks you are allowed to do this. Then it validates the object, and admission controllers get their turn. They can modify your pod or reject it outright. Then it writes the pod to etcd. The write is the commitment. Your pod now exists, it is also going nowhere. Its phase is pending and its node name field is empty. That empty field is the entire job posting. Kube-control already returned success. Your pod has not been placed. Now the scheduler, which has been watching the API server this whole time. It holds an open watch for pods with no node name set. Your pod appears in that stream and the cycle begins. Phase 1 is filtering, and it asks only one question. Could this pod run here at all? It walks the nodes and puts each one through a series of plugins. NodeResourcesFit compares the node's spare capacity against your requests. Node affinity checks whether you demanded particular labels. Taint toleration checks whether the node repels you and whether you tolerate it. Volume plugins check that the storage you asked for can actually attach here. One no from any plugin eliminates the node. There is no partial credit. What survives is the feasible set. Could run, not should run. If nothing survives, we are already in the failure case. Hold that thought. Phase 2 is scoring, and the question changes. Not could it run here, but which of these is best? Every feasible node gets a score, and the plugins each get a say. The default resource strategy is least allocated. It prefers the emptier node. That spreads your load out. Flip it, and you bin pack instead. Balanced allocation rewards nodes where CPU and memory stay in proportion. Image locality favors a node that already has your image on disk. Pod affinity pulls you towards certain pods. Anti-affinity pushes you away from them. Topology spread tries to keep your replicas in different zones. Each score is weighted, then summed. The highest total wins. Ties are broken at random, and that is deliberate, not sloppy. Now binding. It is the smallest step in this entire episode. The scheduler makes one write to the pods bind subresource. That sets the node name field to the node it chose. That is it. That is everything the scheduler does. It did not contact the node. It did not pull an image. It did not start anything. It wrote one string and moved on. It is already working on the next pod. Across the boundary, every kubelet is watching that same API server. Each one is looking for pods whose node name matches its own node. Yours now matches exactly one of them. That kubelet picks the pod up, and it is the one with real power. It pulls your image through the container runtime interface. It sets up networking, and it mounts your volumes. It starts your containers, and it reports the status back to the API server, which is where you read it the next time you run kube-control get pods. So say it plainly, because this is the part people get backwards. The scheduler places, the kubelet runs, the two never speak. All of that hangs on a handful of fields in your pod spec. Let us open one and find them. Here is the field that does the most work. Resources, requests. This is what the scheduler reads. This is your claim on the node. Say 500 millicores of CPU and 256 MB of memory. The scheduler now needs a node with at least that much unclaimed. Right underneath it sits resources, limits. It looks almost the same. The scheduler does not read it, not for filtering, not for scoring. Limits are a runtime ceiling enforced by the kubelet through C groups. Requests decide where you land, limits decide what happens once you are there. If you set a limit and no request, Kubernetes copies the limit into the request, which sounds convenient and quietly reserves far more than you meant to. Next, node selector, a plain map of labels the node must carry. Node affinity is the same idea with more grammar and a soft mode. Preferred rules are scoring input. Required rules are filtering input. That distinction decides whether a mismatch costs you points or costs you the node. Tolerations. A taint on a node repels every pod that does not tolerate it. This is how control plane nodes keep your workloads off themselves. Topology spread constraints ask the scheduler to fan replicas across zones. And then the field all of this exists to fill in. Spec, node name, empty when you submitted it. One node name written by the scheduler at the bind step. Everything above is negotiation. This one line is the decision. Notice what is not in this document anywhere. No address for the scheduler, no address for any kubelet. The pod never refers to the things that place it and run it. So watch what happens when the feasible set comes back empty. You apply a deployment. Your pod goes to pending, and it stays there. No error, no crash. Nothing in your application logs because nothing started. Run kube-control describe pod and go to the events at the bottom. There it is, reason failed scheduling. 0 of 5 nodes are available. 3 had insufficient CPU. 2 had a taint you did not tolerate. That one line is the filtering phase, showing its work. Every node was tested, every node said no, and it is telling you why. 3 nodes could not fit your request. That is a capacity problem. 2 nodes rejected you on policy. That is a configuration problem. Those 2 need completely different fixes, and the message separates them for you. Now the part that matters more than the message. The scheduler cannot fix this. It has no power to fix anything. It cannot make a node bigger. It cannot create a node. It cannot evict something else to make room outside of preemption. All it can do is write an event and try again later. It will keep retrying quietly for as long as the pod exists. If you run the cluster autoscaler, that is what watches for this. It sees unschedulable pods and it adds a node. Then scheduling succeeds. But notice how that works. The autoscaler is another watcher. It read the same record and reacted exactly like everything else here. Now the opposite mistake, which is worse because it looks fine, you set your requests far below what your container actually uses. Filtering is generous, so the scheduler packs many pods onto one node. Every one of them fits on paper. The node is oversubscribed in reality. Then real traffic arrives and the node runs out of memory. The kubelet starts evicting pods to save the node. Your pod dies on a node it was never really going to fit on. The scheduler did nothing wrong. It believed the number you gave it. So here's the boundary lesson. Kubernetes does not have a component that is in charge. It has a shared record and a crowd of things watching it. The scheduler's entire power is one field it is allowed to write. The kubelet's power is that it will act on what it reads there. Neither trusts the other, neither can reach the other. They agree because they are reading the same document, which means your requests are not a hint. They are the input to the decision. So go and check one thing today. Pull up a workload you run and look for resources, requests. If it is missing, the scheduler has been guessing on your behalf. If it is copied from limits, you are holding capacity you never asked for. Every system has a line where trust changes hands. In Kubernetes, it runs straight through the API server and nothing crosses it directly. That is one more boundary drawn. If this made something in your stack, click subscribe. There's a new one every day, and the next one is already in the queue. I'm Nancy. I will see you at the next boundary.